Alright, hopefully you guys have done this, but let's finish off this question here. So let's just label our red graph here. So we have y is equal to the log 4 of x. And from here we're done. So here we sketched the graph of y is equal to log base 4, x plus 4 minus 5. And I guess now we just need to finish that last little bit there. So we did sketch it. Now we just need to state the domain, the range, the x-intercept, the y-intercept, and the equation of the asymptote. And let's write this, I'm just going to write it in this little space here. Alright, so here we have our domain. Our domain, if you look at that graph, so we have our domain with x such that x must be greater than -4, where x is an element of all real numbers. Alright, so let's scroll up to our graph there. So here you guys can see that. So here x must be greater than, and if you guys notice here looking at those values, if we were to say do those values for our x minus 4 and y minus 5, if we did that, what we'd see is that this here, it will never touch your x. You'll never touch that x is equal to -4. It'll never cross that point. And if you guys actually put those points in, if you guys got a table of values from your graphing calculator, that's exactly what you would see. So even if you notice here, you would subtract 4 from your x values. So it would be 4, so it'd be, I guess, 1/16 minus, and that's going to be 3 point some number. I think it's like 3.9, I think I was saying. So it gets 3.9 and keeps getting to that, keeps getting really, really close, I guess the farther down you go. But it keeps getting really close to 4, but it will never actually touch 4. So just by looking at that there, we can say that our domain there is x such that x must be greater than -4, where x is an element of all real numbers. Moving on to our range, we have r, where y such that, and in this case we have y is an element of all real numbers. That's a little bit different than when we were looking at, so remember I said that when we were looking at our exponential functions, they kind of switched there. So here, in this case, when we're dealing with logs, we have y is an element of all real numbers, and when we're looking at exponential functions, that's where your x was an element of all real numbers. So they kind of flip-flopped there. Alright, so then we're going to be moving on to our x-intercept. That's where that crosses that x-axis. We're just scrolling up here. And here you notice our x-axis is not going to happen for a really long time. It's going to keep on going. It's going to take its sweet time. So what we can do is, if we can't see that from our graph, if you can't adjust those windows, what we can do is let's solve for it. So that is where y is equal to 0. So we have 0 is equal to log 4 of x plus 4 minus 5. Then we're going to solve for our logarithmic function, so we'll move -5 to their side, so we'll add it. So 5 is equal to log 4 of x plus 4. Then when we have it in this sort of form, we can write this into exponential form. So here our base is 4, your exponent is 5, and your number there is x plus 4. So we have 4 to the power of 5 is equal to x plus 4. So from there, I'm just going to scroll on down, ladies. So from there, let's solve what is 4 cubed, or what is 4 to the power of 5, sorry. So that is equal to, so you guys put that into your calculator, 1024. And that's equal to x plus 4. Then we'll solve for x, so we'll move 4 to the other side, so we'll subtract 4. And what we have is that x is equal to 1020. So that is where your x-intercept is. So here we're at y was equal to 0, and we're at 1020 and 0. So that there is our coordinate for our x-intercept. So now moving on to our y-intercept. We're just going to use our graph for that one. We didn't have a table of values for our actual transformed function, so we're just going to go to our graph there. And moving on up here, so that is where it crosses that y-axis. So here we're at y is equal to -4. So I'm going to scroll on down here. So here, this is when x is equal to 0. And there we had y was equal to -4. Alright, so moving on to the last one, we found our domain range, x and y intercepts. Now we just need to do our asymptote. Alright, so looking at that, I'm going to scroll on back up there. And that's similar to, or I guess it's related to how we're going to find our domain. So that is where, that line where our graph is going to get really, really close to, but will never actually touch. And so that is kind of, you can even take that directly from your domain. So here we could say that our vertical asymptote, remember vertical is going up and down. So the vertical asymptote is at x is equal to -4. So it doesn't ever cross that point when x is equal to -4. Okay? Alright, I'm going to erase all of this wonderful, wonderful stuff, and we're going to move on to example number 2. And I just want to, before I erase this, I just want to talk about how we're going to solve this one. So we're going to go back to this wonderful graph, or this little chart that I kind of mentioned, but you guys, I don't know, maybe you didn't have a clue what I was talking about there. So we're actually going to look at that example where we take a look at 2 different table values, or I guess charts, and we're going to see how we can get a graph from that, okay? Alright, so here for question number 2, we need to graph y is equal to log 9 of x, and then we need to sketch the graph 2 log 9 4x. So we're graphing its original function and then its transformed function. So at this point we need to state any invariant points, and that is any points in common. We're going to do that with this one and the next question. I didn't specifically say it in that one, but that's okay. We're going to see why I'm going to say that. It was kind of a silly point to say it in this, asking this question, but we'll find out why it was kind of a silly question. Okay, so for this one we're going to create 2 tables of values. So for our first one we're going to be looking at log of 9x, and the other one we're going to be looking at 2 log 9 4x. Okay, so let's just look at the log of 9x. So if we change it into exponential form, we have 9y is equal to x. So with that one, we're going to be choosing those y values. So we're going to have -2, -1, 0, and 1. And 2, sorry. And for those, we're going to plug those values in. So we have 9 to the -2. That's equal to 1 over 81. 9 to the -1 is equal to 1 over 9. 9 to the power of 0 is equal to 1. 9 to the power of 1 is equal to 9. And lastly, 9 squared is equal to 81. So from here we can already start to graph if you want to, but while we're doing tables of values, we can do that at the same time. So, but if you guys wanted to, at this point, you only need this one graph, then you guys can apply your parameters. But if you wanted to, let's take a look at this transform function. Let's look at that table value. So what we're going to do is we're going to have our original coordinate xy from this table value, and then we're going to apply those parameters. So those parameters here, we had this 2 in front of the log. That is your a value, that's equal to 2, and your b value is 4, that's that value sitting right beside that x. So b is equal to 4, which means that it's going to have a stretch of 1 over 4. So that's going to be the stretch by that factor of, okay? So what's going to happen is that our x value is affected by b, so we're going to have x divided by b, and this a value here, 2, is what affects our y, so we have 2y, and that's what our coordinate's going to be. So we're going to take these exact same x and y coordinates and apply those transformations. So that's kind of along with the lines of where I was going with that little table values above. So we're going to take, we have 1 over 81 and -2. We're going to apply these transformations. So let's divide 1 over 81, let's divide that by 4. We're going to end up with this really crazy small decimal. Let's have some fun, I guess, when graphing this. Wonderful. That is equal to 1 over, if you guys put that into your calculators, you should get 324. And then 2 times y, so 2 times -2 is -4. So that's one coordinate for there. Then our other one here, we had 1 over 9 and -1. Apply those parameters. We had, or I guess what we'll have, sorry, we shouldn't have x there. So we'll have x, which is 1 over 9, divide that by 4, which is 1 over 36, and then 2 times that y value, so it'd be negative 2. Then we're going to do this for the, I guess for the rest of them. Alright, and sorry for my little line. Alright, so look at the next one. We had 1 and 0. So 1 divide that by 4 is 1/4. And 0 times 2 is just 0. And for next point we had 9 and 1. So from there we have 9 divide that by 4. We can leave it as 9 over 4. And 1 times 2 is 2. Then for next value we have 81 and 2. And so we're going to divide that x value by 4. So we have 81 over 4. And 2 times 2 is 4. Alright. So from there we have, this should be hopefully enough for us to graph. Some of these values are going to be super crazy, but we don't need to graph those really big ones. As long as we get the gist of what's going on, that's pretty much the most important thing. So say for example this 2 and 81, I'm pretty sure this one here, we don't need to graph. That is insane. Maybe along these lines there, we're getting pretty close there, but you know what, whatever, we'll graph it. But just going up to an 81 and then trying to compare that with 1 over 81, that's crazy. Okay, so first off we're gonna graph log 9 of x. I'm gonna do that one in red. So this one's also a nice chart because it kind of sums it all up in one little area here. So here we have, I guess we should first label our values, so we'll go by 2's. And then we'll label our y-axis, and I'm going to use the same values. Okay, so from here, we're going to start graphing our log 9 of x. So we have x is equal to 1 over 81, so it's pretty much going to be on that x-axis there, and y is at negative 2 there. Then we have 1 over 9 is equal to, or we have y's negative 1 there. Then we have 1 and 0. And then x is equal to 9 and 1. And we're not going to even bother with 81 and 2. That is a little bit ridiculous. So drawing that out there, we're going to stick along as close to our x-axis, but it should not be actually, I guess, on it. Alright. That is approximately what our log 9 of x is. I'm going to change colors here for our different log, but I guess I'll quickly label this one here. So we have y is equal to log 9 of x. It's going to look like a bit of a jumble, but hopefully yours doesn't. Alright, so here we're at, we're going to start graphing 2 log 9 4x. So here we have, our first one is 1, divide that by 324, so extremely, extremely small. That is when y is at negative 4, so we're going to be looking at right about, maybe somewhere around there. And then our second point, we have 1 over 36 for x, and y is equal to negative 2. Then we have 1/4 and 0. Then we have 9 over 4 and 2. That's at about 2.25, and y is equal to 2 there. Somewhere maybe like that. And then we're not even bothered with that other one, so here we're going to connect those dots. Oops, it should not cross that axis there, sorry. So it's going to look maybe something along those lines, and we'll label that y is equal to 2 log 9 4x. So mine, I have a little bit of a shaky hand. I'm using a writing pad here, so try and make yours look as nice as possible. You guys can check this using your graphing calculator. And what's a little bit confusing is that because these values here are so small, we have 1 over 81 and 1 over 324, it's basically going to look like they're touching, but these graphs are not overlapping though.